Today we'll be classifying numbers, classifying real numbers. The classifications will include real, irrational, rational, integers, whole numbers, and natural numbers. So here's a diagram that shows all the relationships of the different sets of numbers. All the numbers in this diagram are real numbers. So let's first look at the natural numbers. 1, 2, 3, 4. This is the set of natural numbers. If we add 0 to the set of natural numbers, we've created the set of whole numbers. 0, 1, 2, 3. And if we take the opposites of the natural numbers, we've created the set of integers. -2, -1, 0, 1, and 2. So natural numbers are not only in the set of natural numbers, they're also whole numbers and integers. The number 0 is a whole number and it's an integer. And they're all rational numbers. Rational numbers can be written as a ratio. That's what makes them rational. And a ratio is the same thing as saying as a fraction. So all these numbers can be written as a fraction. All right, let's look at the number 4. Can't we write 4 as 4/1? That's a fraction or a ratio. How about -6? -6/1, that's a fraction or a ratio. So the rational numbers are all these numbers here that can be written as a ratio or a fraction. Now the interesting thing about the rational numbers, when you go ahead and convert any of these fractions to a decimal, you're going to either get a whole number or an integer here, or these over here you're going to get two types of decimals. You're going to get one that terminates or ends, or you're going to get a repeating decimal. So let's take a look at these fractions we have here. Let's look at their decimals. So it's a rational number because we can write it as a fraction. So 7 divided by 3 or 7/3. And if I convert that to a decimal, it's a repeating decimal. How about -5/9? That also is a repeating decimal. How about 2/3? That's a repeating decimal. How about -1/5? Well, that's a terminating or an ending decimal. It's just 0.2. How about 3/8? That's a decimal that terminates or ends. And how about 1/2? It's 0.5. That also is a fraction that terminates or ends. So rational numbers are all these numbers because they can be written as a ratio or a fraction. The other classification or set that we have within the real numbers are irrational numbers. And these are numbers that can't be written as a ratio or a fraction because their decimals never end. And instead of writing it all out, we use the square root sign. So let's look at some of these. One of the most one we're familiar with is pi. So let's look at pi, and we can see that's a decimal. It's not ending, and it doesn't repeat. So it's irrational. Let's look at the other ones. Let's look at those other square roots. They're irrational numbers, right? The square root of 2. So if I look at the decimal of the square root of 2, it doesn't repeat or end. Square root of 3. That decimal doesn't repeat or end. Square root of 5. That decimal doesn't repeat or end. Square root of 7. That doesn't repeat or end. And the square root of a -5. And that one doesn't repeat or end. So that's what makes up the irrational numbers. So today we're going to classify them, and we're going to use our a letter to represent each classification instead of writing out the word. So instead of writing the word real, we're going to write the capital R. And instead of writing irrational, we're going to write the capital I. Now for rational, it begins with an R, but we've already used the R for real. So we're going to use the letter Q. Integers, well, we've already used I for irrational, so we're going to use the letter Z. For whole, we're going to use W. And for natural, we're going to use N. So this is just a shorter way instead of writing out the words. So we're going to work a few examples together. This first example, we have the ratio 20/4, 20/4. But before we classify this, we want to see if we can simplify it. And we can. 20/4 is equal to 5. Well, 5, that's a natural number. So let's pick up all the different classifications for the number 5. 5 is a natural number. We could just write the letter N. It's also a whole number, so write W. Integer, we'd write the letter Z. And it's rational, so we'd write the letter Q. And it's also real, so we'd write R. As you can see, 5 here, it's made up of all these sets. Next example is the square root of 64. Well, let's simplify the square root of 64. That's a perfect square. The square root of 64 is 8. So 8 is the number we're going to classify. So 8's right here, so we know it's N, a natural number, W, a whole number, Z for an integer, Q for rational, and R for real. Number 3, the square root of 13. Well, can we simplify the square root of 13? I don't think so. That's not a perfect square, is it? Let's look at the decimal on the calculator. The square root of 13. Well, if that decimal doesn't end or repeat, and it's got that square root, so that's an irrational number. So it's an I. And irrational numbers are real numbers. And our final example is 5/12. So it's a ratio, so I know it's rational. Is it an integer? No. Whole number? Natural? No. So it's a rational number and it's real. And let's look at that. Since it's in this rational thing and it's a decimal here, if we do the decimal, let's look. Is the decimal repeating or is it does it terminate? It's repeating. So that's how you classify numbers.